Hello everyone, welcome back to our channel. Here we share beginner-friendly coding tutorials in Scratch, blocks, web programming, and many more. So today we are going to create a pet feeder control using TinkerCad and Arduino. So as you can see, this is our copy of the pet feeder control. So there are like different LED lights, and then there's like buttons, and then there's like a micro, like this is like the feeder thing, so it will kind of spin. So what are we going to do is actually we're going to push the button, so it kind of makes some lights gonna light up. Yeah, so the light's gonna light up. So it depends on how long. For example, we're just gonna wait for 1 minute or 5 minutes or 15 minutes like that. Afterwards, it's just gonna spin, so it kind of works like a pet feeder thing. So let's get started. So we'll start by creating our board first. So there are some few things that we require. For example, we need 5 resistors, 4 270 ohm resistor, and then 110k ohm resistor, and then there's one button, and 4 LED lights, a small breadboard, Arduino Uno R3, and then there's a very special thing. It's called micro servo. So first of all, we're just going to drag the Arduino Uno R3 out first and then put it slightly at the bottom of the screen. And there is a, okay, I'm going to search for the mini breadboard. Yep. I'm going to place it on top of our Arduino Uno a little bit top. And now we're going to put the LED lights on top of the breadboard, top left corner. We're going to put 4 of them. So make it into a horizontal line with all the LED lights. And for the resistor, we're going to put 4 of them on the middle right inside the Arduino Uno. So put 4 of them first. Right, so for all of them, make sure to change it to 270 ohm for each resistor. Right, so okay, we finished our setup inside the board, but however, we still have the push button and also a 10k ohm resistor. We're not going to put it inside the breadboard. Instead, we're just going to put it in between the mini breadboard and then also as well as like the Arduino. So we adjust it a little bit, and then the resistor, going to put it next to the red button. Make sure that it's like 10k. Right. So the last thing we're gonna get from this components are micro servo, which is the most important part actually. So we're gonna put it next to the Arduino Uno on its right side. So right, basically we're done. Now we can do some wiring. So the right leg of each LED lights, connect them with each of the resistors. So the first I'm gonna link it that. The lights of the resistor. For the left leg, we're going to connect them with the GND, which is the ground. So find the intersection between the first right LED leg and then the resistors, and the whole like that. So we're just going to click on that, and then we are going to link it to the GND. So right, so this is the GND, the ground, and all we have to do is link our right leg of our resistors to the ground. So we finished the circuit. All we have to do is actually linking our wires back to our pins. So connect our 4 resistors to pin 11 to pin 8. Now we finish all of our connections between the breadboard and then the LED lights. So next part, we're going to connect our button with our Arduino Uno and then make it into a circuit. So first of all, link your top left leg of your button to pin 12, like that. And then for the positive one, which is the power one, we're going to get our bottom right leg of our button, and then we're going to connect them to our 5 volts pin here. So we connect them. Awesome. So the only one left is actually the resistor. So for your bottom left leg, okay, so extend it and then connect with our 10K resistor. And then afterwards, we're going to connect the bottom part of our resistor to the ground again. So that's it. Okay, so we finish our LED lights and then our buttons. There's nothing on the top right corner of our button, so don't worry about that. All right, so for our micro servo, there are 3 pins on top of that. So for the left one, actually that's the ground. So obviously we're going to connect it to the ground inside our Uno. So extend it and then connect it to the ground together. All right, so in the middle one, that is actually the power wire. So we're going to connect it with our 5 volts, again, with our button. So, all right, so the last one is actually connected to the pin, so it kind of works with it. So, right, the last one, drag it out, connect it to pin 3. All right, so basically we finished the setup of our thing, so we can actually move on to our coding. So first of all, inside our coding part, we are still at the blocks part, but in this project, since like that's a little bit more fun, so we are not going to use the blocks, so change it to text. So like that. Now, before setup and loop and declaring any type of fields, we have to do something with the include servo, since this is like an extension. So we have to get the hashtag include in the servo.h. So this one. All right, afterwards, we are going to do some declaring some field first. First of all, we are going to change our wait time prescaler. So now we're going to get it constant long prescaler. And our prescaler is basically 1 minute, so 6,660 60,000 milliseconds. So this is the prescaler. And later on, we're just going to change our time interval between, for example, 1 to 15 minutes or 5 minutes to 17 minutes, something for longer time. So all we're going to use is this prescaler. And now declare our servo type, my servo. And we're going to set our time step pin as 12, like our button. So this is our time step pin. And now we're going to set by LED pin. So those are the time mark. So byte 1 min mark equals to pin 8. And I'm going to copy and paste for 3 more times because it's for pin 9, pin 10, and pin 11. So 4 up to 4 and 8. 10, and 11. Right, so we are also setting our time set input as 1, our pet. So byte time set input equals 1. That. Okay, so in order to avoid our button command to execute multiple times, we have to create a boolean, which is button activated, equals to false. So, all right, so for our next thing, we're just going to set up our time stamp. So long now equals to 0, so which means nothing yet, nothing happens yet. And long row time mark equals to 0. And now we're going to do the time row counter. So long time to row equals 0. Great. Now we've finished all our declaration of our fields, so we can actually move on to our setup. First of all, we have to set up our LEDs, we have to set up our buttons, and our servo. So 3 things. Now, we're going to get the pin mode first, and our first minute, so which is our pin 8. And I'm going to copy this for 3 times again, since it's like, oh, for pin 9, 10, and 11. So 2 minutes, 4 minutes, and 8 minutes. All right, so for our next thing, we are going to digital write our first min mark as high. So this is like every time when we start our setup, we're just going to have like the first minute, 1 minute countdown as our like default setup. So min mark as high. Like that. All right, so for our next thing, we're going to set our time to row as our time set input times our prescaler. So time to row equals to type is long and time set input and times prescaler. Like that. And well, first of all, we're going to set our pin mode as our output, our 13 pin mode. And we're going to set our time set pin as our input. Like that. Okay. The next thing we're going to do is actually we're going to attach our pin 3 to our servo control. So this is like the original position, right? So cool. So row time mark, oops, time mark equals to milliseconds. And we're going to begin our server. All right, so for the purpose of debugging, we actually want to print out something for testing. So 0 print time to row. And 0 print line time to row. And then 0 print prescaler and 0 print line prescaler. All right. we finished our setup for all the buttons, LED lights, and as well as like our servo. So for the loop part, we have a couple of things to do. First of all, we are going to see if our button is actually pushed. We also want to see our time input and to do something to wait until it's kind of turns for our feeder. So first of all, we're going to do our first condition, which is if our button is activated, which is true. So if button activated, and now 400, oops, it's less than equals to 5. If this happens, we want to actually see some changes. So button activated equals to false. All right, so this is our first condition. For our second condition, we want to check if button is not activated, and then we want to see our time set pin, so how many minutes we have set it to. So if digital read time set pin and not button activated, so if our digital read time set pin and not button activated, we want to set something. So time set input equals to time set input plus 1. And well, since we are going to limit our time set input to maximum value to 15, since we only have 4 LED lights, so that's like the maximum value for the indicator. So we're just going to set it, if we want to be like larger than 15, we're just going to set it back to 1. So if time set input is larger than 15, we are going to set our time set input back to 1, like that. Different more than 15. Okay, so we're going to set our digital write back to low for all our pins. Okay, now we're going to copy 2 times for the 2 minutes, 4 minutes, and 8 minutes mark. So yeah, and then well, we're going to check our pins, or actually if that's actually high or low. So we are going to set up some booleans, some local variables. So boolean bit 0, bit 1, bit 2, and bit 3. All right. So for our bit 0, which is bit read time set input 0, like that. So yeah, 3 more times, bit 1, bit 2, bit 3, and read is 1, 2, and 3, like that. Okay, so for all of these, if bit 0, for example, we are going to digital write our first minutes mark as high. So and for output 1, 2, 3 as well. So after that, we're going to calculate the wait time for our next row. So time to row equals to long times set input and times pre-scalar. Okay, so we're going to activate our button again. If it's true. Okay, so the next thing, just for the debugging purposes, we're going to do some serial port line. Time set input and time to row and serial print line. It's time to row. So these are the debuggings for our first condition. So for our second one, we are going to row our circle after we read all of our pins. So if our circle only row only if the time is actually larger than our counter time. So row time mark is larger than time to row, like that. And we're going to do something again. Okay, so my servo right 180, so it's going to turn 180 degrees and then delay for 2 seconds and then change back to its original position. That. Okay, so we're going to save our current row time for our next row. So that's why we have to do our row time mark as well. Row time mark and milliseconds. And for our debugging purposes as well, we are going to print some serial print line. And serial. Time to row. Like that. Perfect. So we finish our second condition. So for our third thing, we have to do is the only thing we have to do is actually update our current time. So now equals to milliseconds. So yeah. Okay. So for our onboard LED, we actually wanted to have them like work on something as well, but this is not as important as the first two if condition. But we're going to do that too. So if now 1000 less than equals 5 and our digital rate is not equal to 13. We're going to digital write our 13 aside and also our digital rate, it's 13 and our time right now is less than 1, less than equals to 150. And we're going to digital write our 1013 as low. So basically, that's it for our project for our coding part. So we can actually try it out. It should be doing something. before. So, okay, so there are some problems with my code. We're going to debug that right now. Yeah, so it's working. Yeah, capitalization, different capitals, and as well as like the spelling really affects your code. Okay, so it's actually working. So you can see that it's like counting up right now to like 7 or 8 seconds. We're not going to wait until 1 minute, but yeah, so here's the code. So that's all for today. So in this tutorial, we create a pet feeder control using Arduino and TinkerCad, and inside TinkerCad, we also use my servo, like the servo control. Well, I hope you like this video, and don't forget to subscribe our other videos. Also check out the two of them while you're waiting for the next video. So thanks, bye.